All right. So this session would be a recording, and after that, I will upload the recording to Moodle. Okay, that makes sense, everyone? Okay. So um, our course, the PETR 2135, so the first topic of our course today um, is production casing, liners, completion equipments, and the methods. Okay, so can you see the screen? Can anyone confirm me?
Yep, yep.
Yeah.
Okay,
Yep.
perfect.
Yes, sir.
So, okay, so reservoir, petroleum reservoir. So the petroleum reservoir, or like in offshore or onshore, it forms the same process, like that's very similar thing. It could be in offshore or it could be in onshore, but the process is like we had like the organic life forms like millions of years back, and these organic life forms actually went to under tremendous heat and pressure under the earth, and without the absence of oxygen actually converted them to oil and gas. Now these oil and gases, like those naturally wanted to come to the earth, like in the earth's surface. Why? Because at the earth's surface the pressure is lower than the um, uh, down below of earth. So over the time, lots of these gas and oils actually swept through and came to the earth, but many of those actually trapped inside. Why they trapped inside? Because they had something called trap. Okay, it's pretty straightforward. Like we have named those geological formations as traps. So these traps could be in different types. It could be anticline traps or fold trap. It could be a fault trap. It could be a salt dome, which is a type of anticline trap, and we got the stratigraphic traps. So probably you all know about these things from the other courses. This is a very first nature. I mean, very primary thing we're actually learning for the first couple of slides. So you know how these anticline traps looks like. This is the fault trap, this is the salt dome, and the stratigraphic traps. And we also know that reservoir, the top portion, the top layer, or the natural gas, and then we have the oil, the rock oil, and the oil is inside what? Inside a type of rock, and those rock we call them. It got high porosity and high permeability. Okay, so this uh, rock oil actually stays in that rock, and the later layers are the waters. Okay, so that's how these reservoirs actually form. Now if we want to take the rock oil out, so what we need to do, we need to drill the hole to the these sedimentary rocks. Okay, and then we can actually get the oil. So usually the oil comes naturally. Why? Because the pressure is very high in here in this zone, but the pressure is low here. So it is the nature of the fluids that it fluids move from the higher pressure to the lower pressure. But however, sometimes these oils will not travel voluntarily. Why? Why it could be happen? For instance, the oil sands in Alberta. Okay, so the oil sands contain high tar. So these tars, um, just 1 second. So these tars can can be very viscous, and it might not come in a natural lift. Also, not only the tars, if the rock is less permeable or it got a lower porosity, at that time it might not come naturally. So we need to do something else. We call it enhanced recovery. And a fracking is a type of the enhanced recovery too. So we'll learn about that later these slides. Okay. So let's move along to the resources. So in PETR 1131 and also 1161, we have looked all about these operations, like the pretty basic level, okay? How we drill the well, and once the drilling is completed, then what we do? Then we actually bring out the production team, and they start doing the production. But in the meantime, we sometimes seal off the reservoir. Okay, seal off with what? With a Christmas tree. And so what will happen in this class, we will concentrate more on getting the oil and gas out from the reservoir to the pipeline. Okay, so usually we call this upstream, upstream level of oil and gas facility. Now, what is upstream and what are the downstream? And if there is upstream and downstream, is there any midstream? Yes, there is a midstream too. So let's learn about this thing. So the first step we do to get the oil and gas. The first stage is we call it, as you know, exploration, and after that, when we are pretty confident that there's oil and gas, so we deploy the drilling team. So basically, the whole drilling process right before the production, as well as the production right before the processing, we call it upstream. Okay, so that means through the drilling to production, but right before the processing. Okay, so we call this segment the upstream. That means from the bottom of the earth, we lift the oil and the gas at the top. So that is the upstream level. So what is midstream? So when you get the oil and the gas, so the first thing we do, we actually take it to a separator or a field processing unit. Okay, what does that do? That is actually screening out the impurities initially. For instance, it got the you got the oil, but it got lots of sands, so and waters mixed with that. Okay, so the first thing you need to do is separating it at first. So with the screen, you separate the sand particles, and with a gravity settling tank, you separated the waters, and then you got your crude oil. And if it's the gas, you just need to filter out the the moisture contents and all other stuff. So this is a part of the midstream process. And we do another very important thing at the midstream process, that is sending the oil and gas, this crude oil or like un, um, the unfiltered gas, to the processing unit or the processing center. Okay, so in case of gas, what's happened? Sometimes we process it in the field, and sometimes we actually send it to the gas processing unit for a couple of kilometers distance, and then we process that. But in case of crude oil, we send it to the refineries. Okay, so this the huge network of the pipeline storage and the tankers. Okay, so this is the midstream section. Okay, so all the oil and gas transmission pipelines, like this big transmission pipeline. For instance, one of the example could be Keystone XL pipeline. Okay, that is a type of a transmission pipeline. So all of these are a part of the midstream process. And what is downstream? The downstream is right after you have received the oil or the gas at the refinery or to the gas processing unit, what you do, you will refine it, okay, and you will refine it based on your client's need or the market needs. You just define it, and after that you send it to your end user. So your end user could be um, airport, fueling to the jet fuels, or could be even you into the go to the gas station and get the oil for your car, or it could be the chemical and petrochemical manufacturing plants where they produce thousands of different types of materials, naming paint, plastics, so many other different items. Okay, so all these items are the downstream section. So now we know what are the upstream, the midstream, and the downstream. Okay, let's move on. So the completion, um, as we are saying about that, so it is mainly an upstream level of work because it's a part of the production. Okay, so the the drilling part, we already know much about the drilling area in our course 1131 and 1161, so we'll actually skip that part. So we'll start from the completion. Okay, so there are many different types of completions we have. We use the same types of the equipment, for instance, the tubing, the packers and plugs, perforation guns, casing shoes, acidizing. So acidizing is the process. We will actually explain all these, and we will also explain about like the factors that we should actually consider when we choose the completion. Like what are the why we use different types or different methods of the using the completion. It could depends on the sand content. Okay, sand content of the reservoir, the type of fluid the reservoir got. As I said, if your oil is too thick, and thick means the viscosity is very high, you need a special treatment. So you need a different type of perforation guns. Okay, and the reservoir drive also. For instance, you got low, I mean, not that very high pressure into the reservoir, so you need some artificial lifting. Okay, so that's the case you need to do consider too. So there are so many different considerations we have to take to choose our right options. Okay, now let's go a little bit touch about the drilling and casing beforehand, reading about the completion, because drilling and casing is the most important part of the production process. Based on the casing structure, then we actually decide what types of completion methods we would actually use, and what types of equipment we would use, what types of tubes we would use. Okay, so let's recall our drilling knowledge from the previous courses. So if you remember, the first thing we do is to set up the conductor casing. And what is conductor casing? It is a huge, a big pipe. Okay, so we put that conductor casing, and on the top of conductor casing we have the drilling rig. Okay, and when we put the conductor casing, then we um, start drilling the area, and after that we cement. Why we cement it from the other parts? If we do not do that, you see these soils on the different sides, these will choke down and destroy our hole, the drill hole. Okay, that's why we actually use the cementing. So the first thing we use the conductor casing. So this is one of the example. Okay, and then we attached the line of the strings. Okay, the casings. It's kind of look like sometimes I frequently say it looks like a TV antenna, you can make a short, and when you actually pull it up, you can actually pull it to the long, okay, or a Russian doll. I'll give you some example later on. So, the drilling and oil and gas well is generally the repetition of this following sequence. Remember this sequence. So, the first thing we do what? We drill a hole. Then we put a casing like this. At first, we drill a hole, we put a casing. And after we put the casing, what we need to do? We need to cement the casing, okay? Just like you do something and then you have to glue it. Otherwise, it will be shaky, and it can actually destroy the whole formation. Whole formation. And after you do that, what's the next step? Drill a smaller hole. Like when you set up the conductor casing, it was a bigger hole. After that, you glue and do everything, then you drill the smaller hole like this one. And then again you put the metal casing and cement the casing. Then you drill another smaller hole like that, and again put the casing, cement the casing, drill another smaller hole, put the casing, cement the casing, and so on. Alright, so this is the sequence of the drilling and oil and gas. Now the type of the casing. So we were saying like we will actually repeat these jobs. So when we actually repeat these jobs, so that means what? That means the diameter of the casings are reducing up to what level? Let's learn about that. So the contactor casing, as you can see from this picture, it's the largest diameter, okay, and it holds the surface and it isolates the well from the surface aquifers or other things. Surface casing right after the conductor casing, and it isolates from the water aquifers. It also allows the use of BOP. We'll explain that later. What is BOP? A very important piece of tool. It's called blowout preventer. Okay, intermediate casing is the casing between the surface casing and the production casing. So intermediate casing could be a long. It's not like just one case. It would be the stack of many cases. Okay, just one second. Stack of many cases. So this is the intermediate casing, and then we have a production casing. Okay, so the final casing we have for the production. So production casing, that's isolate the zone containing the oil and gas from the subsurface formation, and it also use up to pump the hydraulic fracturing fluids in the producing the formation without contacting with like the other formation in the well bore. Okay, so depending on the type of the well or the type of the process or many other things, we can use a chain or maybe one, maybe more of intermediate casing. So it totally depends. Now this is a rig. The rig looked like that. So this is the milestones, everything. So let's see the sketch of the rig. Okay, it's like the very similar thing. So the first we have, as you know, like the crown block and the derrick, and you got a pulley system. We got like the a high powered motor um, to do the pilings. Okay, we got the swivels, standpipe, Kelly, and then we do the real drilling. Then we got the drill bits. Okay, so what the job of the drill bit? Drill bit actually it moves and it to the drilling, to the drilling pipe, and we put the after we drill a little bit, we put the casing, and then we do the cementing, and we drill again, and repeat the same job. Okay. Now I told you about like the Russian doll. Probably many of you have seen that. Okay, so I think like they have some names also. I forgot the names. I heard from one of my Russian friend the names, but I don't remember that. It was a long time back. So Anyways, so the big one, okay, is like the conductor casing, okay, and the smallest one we got is like what? Is the production casing. Remember here, the production casing, like that. Okay, so yeah, thank you, Sergey. Okay, perfect. Yeah, it's called matreshka. Yeah, exactly. Thank you very much. So yeah, so now it looks more familiar, right? So it's exactly like that, and as we saw, if there's a video attached, I will actually show you the video later. Okay, you have the link, and that's a very excellent video. You should actually watch. Okay, so when you drill and put the conductor casing. After that, we do the cement lining inside, and after that, we'll put the casings and cement lining inside, and so on until the production casing actually go in there. Okay, so this is a kind of like a stick diagram, like the 2D version of the stick diagram. How the casing actually look like. It's a kind of like more elaborated version. Okay, so how you actually put the casing. Now I'll show you an interesting thing that is like, that could evoke a question to you. That is, as I said, like you at first you put the big conductor casing. These are like the diameter of the conductor casing, and then you use the surface casing and line casing, and the end you'll have the production casing. Now the conductor casing would be a um, bigger diameter, okay, the larger diameter, sorry, but the production line would be in a smaller diameter. So what do you think? During this planning process, should we be planning from the ground level to the reservoir, or from the reservoir level to the ground level? Or rephrasing the question, like should we define the diameter of the conductor casing first and then the production casing, or should we design the, sorry, should we select the production casing first, then we'll do the conductor casing. So I'll just the question and answered. It would be a thought-provoking question. Just think about it. Okay, I mean the image already gave a very good hint, but just think about it. All right, so the drilling. So drilling activities, it's not like a rocket science. Even rocket science is pretty common now, and it's not that complex anymore. Okay, so it's just a basic fluid mechanics nowadays. Underwater operations are sometimes way more complicated than rocket science, because the air density is really low and less turbulence. We got the air at the top, but underwater it's really crazy, and we got lots of species underwater. Okay, and the pressure, the down below you go, the pressure becomes way crazy, but the upper atmosphere, the pressure is less. So I think, like, space technology is relatively less complicated than the underwater technology. But anyhow, so this is the link I actually wanted to give you. As I said, please go to the link and watch the video. It's a very good and helpful video actually. Okay, packers. So from here we start on our production work. So when we use all the when you actually do the drilling and set up all the conductors, after that we put the packers. So packer is a piece of equipment that can be used to isolate the well from the surface, or to isolate the discrete portion of the well. You see here, it's actually isolate. So it's a there's a rubber element over here is used to create the sealing. Okay, it's sealed off from the bore of the casing wall. So these are the sealings actually, and that's a video actually you can see if you are more interested to work on the packers. Okay, so packers can be activated using the weight set, pull set, or pump pressure, or even the combination. So it's a video you can watch, like how these packers actually work. So the packer, what type of packer we should use? It depends on several factors. For instance, the formation pressure, the hole or casing size, the variance of the wellbore caliper, permanent or retrievable. It totally depends on these. Uh, mainly these factors, but there are some other factors too. Okay, especially formation pressure is very important to choose what types of packers we actually use. Perforation equipment. Well, to explain this thing, I always try to give some physical example, so that very simple example at first. Okay, so the packers and the perforation equipment. Let's give that example. So you have a can of Coke and you want to open that Coke. So what you usually do? We open the bottle. Now remember, the um, reservoir is just like the can of Coke. Um, it's in the Coke we got like the high pressure carbon dioxide inside with the Coca-Cola, but in case of a reservoir, we got crude oil and dissolved gas inside, so it's also just act like a Coke, and it's in very high pressure. Now you opened it up, and what Cokes will do? It will try to come out. So the first thing you need to do is seal it off at first. Okay, no, and that seal we called the BOP, or blowout preventer, and that's actually give a control to the whole process, like it's not to go out. Now, have any one of you? Sorry. Now, the what is packers like? You remember, like when the drilling is done. After that, we put the tubes, just like the packers. Now, just imagine about the Coke can. When you actually open open the can, after that you just put a straw and start um, drinking the Coke. Okay, so that straw you actually put in there is it's the um, kind of like the packer. Now, this is all about the Coke. Now, have you tried drinking the summer drinks from the McDonald's, like the slushy or like the teens, or all of those have the slushies? Okay, so what is slushy? Slushies are like you have ice and the juice, and they just mix it up and crush the ice, and they give you in a cup. Now, when you actually suck and drink the slushy, after a couple of minutes later, you find like the liquids are gone. All you have the ice. Okay, so what do you do after that? You put sometimes to melt the ice. You can wait for that, or what I do sometimes. I just um, blow the ice um, through that pipes. Okay, so that straw. So the perforation is something like that, or sometimes you do what we do. We have these straw. We just stir up the straw a little bit to so that the ice got melted. Okay, perforation is something like that. Perforation equipments actually designed to stir up the reservoir down below. Okay, so this is a type of gun they actually use. We can use some explosive devices, and then we actually set up the explosive charge, and what it do, it perforates, and if any rocks are impermeable or any rock formations are very stiff, just like that ice slushy. Okay, so it got just like ice got melted away when you actually stir up the pipe. The same way it actually perforates. Okay, it actually, the perforate gun actually after setting up the explosive charges or stirring up, it actually open up the reservoir. So the perforation equipment is a kind of like a solid casing that use for the production string when the holes must be created in order to create the communication between the casing and the reservoir. So you drill a little bit, and after that you think like um, you need to make a room, so you have to put the perforation equipment, it explode, make the explosion at the bottom, and then you can actually drill even more or even more. Okay, so the perforations create holes deep into the reservoir which bypass the damage formation. Okay, so I would highly suggest you to watch this video again. You will have a very nice graphic to see what is the perforations actually. Okay, now there is a um, penetration depth. Okay, so depth of the hole created by the perforations. Okay, the type of charge we use and the location of the wellbore you can see. So please watch these videos too. Casing shoe. A casing shoe is used to prevent the drilling fluid in the wellbore from entering the casing. So it's a type of like a non-returning valve. Okay, use that. Acidizing. Okay, so you saw here the perforation equipment, and as I said, we sometimes use the explosions, and after that, it started drilling away. Now um, there's some problem with these explosions. When these explosions happens, I mean, when we actually explode inside, so what happened? There's some small rock formations, rocks pieces will be scattered inside the drill, and it's really hard sometimes to drill along with it. So in that case, we sometimes use acid so that these rocks can actually um, can or the debris, so that these uh, types of formations can actually uh, dissolve. Okay, so acids used at any time during a well the life cycle in order to try to clear the debris. So what are the types of acid we use? We can use the hydrochloric acid, formic acid, acetic acid, and hydrofluoric acid. Now, here is the interesting part. You can see, like, I mean, we use hydrochloric acid, which is lower concentration than sulfuric or like the nitric acid. And if we use like the formic acid and the acetic acid and hydrofluoric acid also, okay, but we don't use very high concentration, high concentrated other types of acid. Why? Because the acids are very corrosive for the even for the machineries we use. Okay, so that's why we use the low concentrated the low power acids. Okay, so the first three, like the HCl, hydroformic, and acetic acid, are used to attack the carbonate minerals. Okay, for instance, calcium carbonate or that types of minerals. So it can actually uh, clear these the carbonates minerals can be dissolved in this acid, and it will clear the path. Or we can use the hydrofluoric acid to dissolve the silicate materials. So hydrofluoric acid got a unique characteristics. It's called etching. That means like it react with the silicate materials and it can easily dissolve that. So we can acidize and make our way clear. So after these things done, we do the tubing when the casings are all installed and we put all the gels, we start putting the tubing. So the production tubing is a tubular pipe which usually run inside the production casing. Okay, um, almost all types of artificial lift require a type of tubing. Okay, so here you can see this is the tube hanger and we put the tubes and these are the casings. Okay, the type of tube, the type of completion. The type of production casing that used depending on the resources that being moved, the depth of the reservoir, the geometry of the well, and the size of the hole drilled. Whether or not there is a possibility to extend the well at later date or not. Now, uh, the types really depends, as we said before, it depends on so many different things. But the first important thing is what type of fluid it got, what would be the pressure, and if we need any artificial lifting or not. So it depends on so many factors. But the common types of completion, including open hole completion, slotted liners, screen liner or gravel pack, cemented liner, perforated casing, and smart completion tools. So open hole completion is just the pretty basic one. You drill it up, you put the hole, you put a pipe inside it, that's it. Now, once it was a very common option, but we don't use it anymore. It's very simple, but the problem is it's too simple, and it don't its yield is very low. Okay, so that's why we don't use that. So you can say the problems are way more than the real benefits. Okay, it's cheaper, it's less equipment required, but it is kind of like obsolete. Less equipment failure, we know that, but it reduces the wellbore stability. It's insufficient on the isolation of the reservoir zones. And of course, if that thing happened, there will be huge kicks, okay, and a huge pressure change. That's another big problem. And the problem is it's the very older technology. People actually don't know about this technology anymore. It's probably like 1920s or 30s technology. We don't use this anymore at all. Okay. Now, what types of completions we use now? Slotted liners. So these are type of like the slotted liners. As you can see, we use these types. We, if we choose to run a production string and into the it should be production. Sorry, into the reservoir, then it must have some allow to pass through. So what does that supposed to mean? That means like you put a tube inside. So here the let me give you the example. It would be easier if I actually give you the example by drawing. For instance, this is the production line. Okay, excuse my drawing. It's very bad, I know. And here we got the crude oils, for instance. Now,
Can't.
oh, you can't see? Okay, sorry. Yes. Just 1 second.
Ready.
Yes, that's the problem of. Um, hmm. Can you see a whiteboard in here?
Yeah,
Okay,
whiteboard idea.
right. Let's see how it actually works. If I can use that or not. All right. I think I can use that, but it got some time lag. Oops. Um, I've never used that before, so I think there is some problems. Just one second.
All right.
It's a sticky note. Let's draw another one. So this is the, for instance, this is the pipeline we have here. Okay, and you have the gas in oil and gas in here. Okay, for now, if it's just the hole you got in here, then what's happened? It can only enter to this area. But however, if you actually design this, for instance, you got like holes, okay, or a type of like slits, make room, okay.
Sorry, we can't able to understand, sir. Your drawing is not showing properly.
Mm, all right. Mm, okay, just one second. I think. Just one second.
Yeah, sure.
All right. I think now you can see. Can you see the paint? Microsoft Paint.
Y yes, now it's perfect. Try now.
All right. Yeah, it's always use the old technology sometimes. All right. So, for instance, this is a hole, and we got like the uh, crude oils in here. Okay. Now, what would happen at this pipeline if it's just only in this direction? Then what could happen actually? Like only you will got the fluid entering in this location, right? But if you actually select your production tube in such a way that you can actually, for instance, you have holes inside the production pipe, okay, for instance, like the small holes you put, or you put some slits like a small doors, okay, like that. So in that case, what will happen? The thing will happen is when you actually um, put it down, this pipeline you put down in there. So these liquids, these crude oils, it would enter. It got multiple channels to enter, right? Okay, and then you can get a bulk flow of crude oil over the pipeline. Okay, can you see that now?
Yeah, yeah, now it's perfect. Thank you.
Okay, sure, no problem. So what's happening here? Actually, the very same thing. Okay, so this is the in the inside the pipeline we have these small slotted rooms. So it can be the horizontal slotted, vertically, or like the single slotted or like the gang slotted. It totally depends on the type of reservoir fluids and also the type of the reservoir. Okay, for instance, give an example. If the reservoir fluid is um, very sticky, okay, in that case we'll need a little bit bigger room for that so that it can actually go inside if the viscosity is very high. Otherwise this gang slotted would actually work perfectly. So it totally depends like how the size of the windows would be. Okay, so the next one you'll see. All right, so this is about like the perforated pipes. We have these mesh. What is the job of these screens? We actually need these screens because sometimes, as I said, there could be small debris and stuff, so we need to screen those debris and only um, try to allow the liquids to go inside. So, okay, that's why we use the liners and the strapping with the wires. Okay, so if we have these types of mesh arrangements, low, the flow rates would be a little bit more higher. So this is like the actually how the perforated uh, pipe looks like. Okay, so it's a very common type of the perforator. We actually use these types of perforators since 1930s actually. Okay, and still we're actually using these types of perforators. Um, Now, when this perforating technology we're talking about, and then the word actually comes in, like the next word comes in is the fracking. Okay, so these two are deeply related. Fracking is a very old technology, started using from the 1950s, and we still actually use the fracking. Sometimes it's combined with the acid, as we show you before, like the how the acid actually works, and also using the explosives. How to use that? Okay. Um, the fracking actually started widely used in 1990s, especially when we start doing the directional drilling. For instance, like the horizontal drillings. Okay, so why we actually do frackings and what's the benefits of horizontal fracking? If you see like the old movies in Texas area, you'd probably see there are like hundreds of pumps are pumping in an area in one area. Okay, lots of like pumps are pumping in there. Why? Because at that time the directional pumping was not discovered. Now, what we can do, we can actually um, use a horizontal drilling also. So now we can just use one um, production line to drill multiple mines, okay, in unidirection or in any direction. So that's why this when this directional drilling actually comes in. At that time, there's another very unique problem started. That is sometimes the rocks or many other like the rocks actually hinder the drilling area. So there's a big solution for that. We put explosive charge, we destroy the rocks, and we start continuing our operation. So that's the thing fracking usually do. So the that is we called the hydraulic fracking. Please go to these videos and you can see like the completion operation. I will not go to this video to show you right now. You can see that by yourself. Okay. Now, how this fracking actually works? The process of the hydraulic fracking is very high pump pressure okay, within the reservoir formation, and the fluid used the fracking contains material used as proppets, okay, which hold the fissures opening and pressure release. And after the pressure released, it cracked down the whole area, and it creates the increasing flow from the oil. Okay, now what are the problems actually happen due to these frackings? The problem is it creates tremor inside and a local earthquake. So that's exactly, and there is another big problem. Sometimes uh, the aquifers, okay, so the water level, the aquifers are inside. When you do the fracking, the earth actually shook, and the aquifer can be contaminated with this oil, okay. So that's a very, very alarming thing. So that's why there is a huge controversy sometimes. The fracking is no good, especially you'll find lots of different areas they're saying like fracking contaminated the ground or even the surface water actually. And as I said, it creates tremor and small earthquakes. So yeah, lots of controversy now we got for the fracking, but still it's one of the dominating technology we actually have right now to get the oil and gas from the ground. So there are so many controversies. Like in 2017, EPA released a report in detailing its finding related with the research for doing the frackings. Like for instance, what types of issues we have the fracking, like water withdrawals for hydraulic fracking in times area got, with the low water availability will create the groundwater pollution and also decline the groundwater resources. That would be another big problem. Spillage could be another big issues the time of fracking. And as you know, we put lots of chemicals, especially acids, in there too. So that could contaminate, that could actually sweep up to the fresh water, and it could contaminate the groundwater. That's another big problem. The injection of hydraulic fracturing of the oil is inadequate with the mechanical integrity, allows gases or liquids to move groundwater to the resources. That's another way groundwater could get the contamination. Another problem is the waste water. Okay, so as we require a huge quantity of the water for the acid wash or in any types of enhanced recovery of the oil and gas. So that's a huge problem. Like we need to take the uh, water inside, but we often do not clean the water, so it creates lots of wastewater, and that's another big issues. So there are lots of problems or like the controversies with the frackings. So if you go to this site, you can find like the whole detail of the the fact sheet from the EPA. Okay, so these are the references, uh, and you can actually go through these references. And I will highly suggest you to watch this video at first. Do you remember the video I showed you? This one. Okay, so you'll have a pretty clear understanding on the whole completion process. So, all right. So, this is all about today's lecture. So I will stop recording right now the lecture.